Hello and welcome to this new session on business analytics using Excel. I'm your instructor Rajesh Durbala. I'm an assistant professor in business analytics and I've been teaching this course for the past few years in various universities and institutions. So the learning outcomes of this session: by the end of this lecture you will be able to understand the concept of normal distribution. Actually, you will be able to understand what normal distribution is all about and apply the concept of normal distributions in real decision making scenarios. Okay, it's not just the understanding of the topic, but you will be able to apply those concepts into your real decision making. Okay, and then you will apply Excel tools to understand the normal distribution concepts, and then you will also use Excel tools to solve some problems on normal distribution, and then you will be able to distinguish between normal and not normal data, and you will also learn how to normalize a given set of data. Okay, so keeping these learning outcomes in mind, we will proceed with today's session. So the first and foremost thing, what normal distribution is all about. Okay, now normal distribution is the spread of data. Okay, and it is the most important of all distributions. We have various forms of distributions, various forms of probability distributions like normal distribution, binomial distribution, exponential distribution, Poisson distribution. Okay, out of all these kind of distributions, normal distribution is the most important of all. And the second point, you have to keep it in mind that it is a continuous distribution. Okay, there are two types of distributions. One is a continuous distribution and the other is a discrete distribution. So normal distribution deals with continuous distribution. It cannot be applied with discrete distribution. Okay, we'll understand what is the difference between normal distribution and continuous distribution and discrete distribution in later slides, but till now you have to keep it in mind that normal distribution is applied only for continuous distributions. The third point is normal distribution forms a symmetric bell-shaped curve. That's a very popular bell-shaped curve that also we will be discussing in one of the forthcoming slides. So the very popular bell-shaped curve, that is the significant or striking feature of normal distribution. Then any particular normal distribution is specified by its mean and standard deviation. These are the two parameters I can say for normal distribution. One is the mean and the other is standard deviation. So these are the two important parameters of normal distribution. Then next is, by changing the mean, the normal distribution shifts to the right or left. Okay, if you are shifting the mean, the normal distribution either shifts to the right or to the left. And similarly, by changing the standard deviation, the spread of the normal distribution increases or decreases. That is to say, it becomes very pointed or it starts becoming very flat. It becomes pointed when you decrease the standard deviation. It starts becoming flat if you increase the standard deviation. Okay. Next, we say that normal distribution is a two-parameter family where the two parameters are the mean and the standard deviation. This is something that we have discussed earlier itself. So normal distribution deals with only two parameters. One is the mean, the other is the standard deviation. Okay. Then what are continuous distributions? So continuous distributions are those which occur in a continuum. That is to say, you are not dealing with a specific data point in the distribution. You are dealing with a set of data, a continuum of data which forms a range. Okay. So instead of a list of possible values, there is a continuum of possible values. Okay, we are not talking of specific values. We are talking of a continuum of values. For example, like 0 and 100. All the possible values between 0 and 100, it forms a continuum. Okay, or all the values which are greater than 0, it forms a continuum. We are not dealing with a specific point or a specific data point or a specific value. Okay, so instead of assigning probability to each values, what we do is we assign the probabilities of between 0 to 1, the probability of 1 that is spread over a continuum. Okay, we know that the total probability of the occurrence of any event is 1. So that probability of 1 is spread over a continuum. Okay, that is what is continuous distribution. So we are dealing with normal distribution, which is a continuous distribution. That is to say, it doesn't deal with a specific data point. It deals with a continuum of data. Okay, and then standardizing and finding Z values. Let me tell you what is standardizing. Okay, now I can use the normal distribution curve to understand or analyze the scores of my students, okay, which could be anything between 0 to 100. Similarly, an astronomer may be interested in calculating the distances between the Earth and various other stars, or maybe other planets or various other galaxies, which can run into some light years. The distance could be measured in light years. Now, if I'm using the same distribution curve for measuring various things like my scores or the prices or the sales or the customer walk-ins or maybe the distance between stars, so how do we put everything on the same normal distribution curve? Okay, so in order to remove the ambiguity and for the convenience sake, the entire data could be compressed on a normal distribution curve in a span or in a continuum which ranges between -3 to +3. Remember this, a continuum which ranges between -3 to +3, 0 being the center. 0 refers to the mean of a normalized or standardized normal distribution, and every standard deviation would be 1. So that means I have 3 standard deviations to the right side and 3 standard deviations to the left side. Okay, so how do we normalize it? Any value can be normalized or standardized by this formula, or the Z value could be found by x minus mu. Mu stands for the mean and sigma stands for the standard deviation. Okay, so this is what this slide is all about. We will practice a standardizing problem and we can understand this better. Okay, now here this is an example. Now calculate the mean and standard deviation of each annual return and then use the standardizing formula to calculate the corresponding Z value. Okay, or calculate Z value directly using Excel standardize function. So let's see. Now this is a problem. Okay, now let us see. I have the formula, right? What is the formula? Do you recollect? Formula is, let us say, X, these annual returns. Okay, first of all, let me understand or let me explain you what this data is all about. We are standardizing the mutual fund returns. I have a set of almost 30 mutual funds. Okay, you can see I have a set of almost 30 mutual funds and their annual returns are given over here. Let me zoom this for you. Okay, I am not able to zoom it. Let us see if I am able to zoom it now. No, I am not able to zoom it. Let us see now. Yeah, now I am able to zoom it for you. Now, so you can see I have 30 mutual funds. Okay, their annual returns are given, their mean return is given, the standard deviation of the returns is also provided. So I am asked to calculate Z values. 1, using the formula. Number 2, using the Excel function. Okay, so let us first use the formula. The formula is, I will type this way. All of you have learnt modeling and how to input formulas, right? So I will input the formula equals to, the formula says X, these are the X values. Okay, this is X, okay, minus mu. Mu is this. Okay, so to avoid any complications, I'll put these things in brackets. Okay, now this has to be divided by my standard deviation. So I'm getting the Z value minus 1.8047. Now very important thing you have to understand, if I get a negative Z value, negative Z value stands, or you have to understand it this way, any Z value which is negative, it falls on the left side of the mean. Any Z value that's positive lies on the right side of the mean. Okay, because mean is 0. You have 3 positive standard deviations on the right side, that is 1, 2 and 3, and you have 3 negative standard deviations on the left side. -1, -2 and -3. So if I get minus 1.8047, this tells me that this would lie on the left side of the mean. Okay. Now how do I calculate z values for all the given values? Now simply if I drag the formula, okay, you can see some errors are occurring. Can you guess why these errors are occurring? The error is because we have to freeze these values, because when I'm dragging them, these values need to be constant. When I drag them, the cells start moving downwards, which would pick wrong values. In the previous sessions, we learned how to, absolute referencing and relative referencing, if you remember. So these two cells have to be referred absolutely. Okay. So this B4, which refers to my mean, has to be frozen by putting a $, and similarly the standard deviation has to be frozen by putting $. Okay. There won't be any change in this value, but now see, when I click, boom, now you can see I have all values calculated properly. Okay. So this is what I have done manually. Now how can Excel do it for me? Let us see. Just put equals to and type standardize. Okay. See, I get this over here. Now what are the values I need for this? I need an X. I have an X. Great. Then I need a mean. I have a mean. Okay. Again, I'll put these $, because I know the reason why. I take my standard deviation. I again put my $. I close the bracket, hit enter. Boom. See, I get the same values. Okay. Now I double click. You can see I have compiled the same list throughout. So this is the beauty of Excel. Now we are in a position to understand how things are normalized. And you can see all the values range between +3 to -3. It is, see, understand one thing, it is not that you cannot get any value greater than 3 or less than -3. The only thing what it is meant is there could be possible values greater than 3, but the probability of the occurrence of such values is practically impossible. Okay. So that's with standardizing.